Okay, we're going to look at section 4.1 homework. So the first question is asking to select the values that are not valid for a probability. Remember that a probability can be any number from 0 to 1. It can't be greater than 1, any decimal, or any percent from 0% to 100%. It cannot be a negative value, and it cannot be greater than 1 or 100%. So this is why 50 over 37 would be greater than 1. 134% is greater than 100%. These two values are between 0 and 1, so they're good. 0 is okay. Negative 1 would not be okay. Probability can never be negative. 55% is a normal probability. It's between 0 and 100%. And then for H, it's greater than 1. All right, moving on to question 2. What is the probability of randomly selecting a heart from a standard 52 card deck? And if you're not familiar with cards, if you don't play cards, you may just have to look that up. But there are 13 cards in a deck that are hearts. So 13 out of 52 would be 0.25. Okay, for this particular problem, we are rolling 2 dice, and we are wanting to see the probability of obtaining certain numbers. So the best thing to do would be to write out all of your outcomes. So we're going to do that. Okay, so I have written out all the outcomes, and the first numbers are the numbers that we would roll with the first dice, and the second number in the order pair is what we would roll if it were the second dice. So let's go back to our question here. The probability of obtaining a sum of 9. So what you have to do is just the hardest part is just writing it out. But a sum of 9, well, that would be 3 and 6 would add up to 9, 4 and 5, 6 and 3, and I believe that is 5 and 4, 4 and 5. Okay, so there's 4. So the probability of rolling a sum of 9 would be 4. And then we have 1, 2, 3, 4, 5, 6, 36 outcomes. So that would be 1/9 when you simplified it. Now let's look at the probability of obtaining a sum of 3 or less. So this time we're looking for a sum of 3 or less. Well, 1 plus 1, 1 plus 2. 2 plus 1, and I believe that is it. So sum of 3 or less would be 3 out of 36, which would simplify to 1/12. Okay. For the last part, the probability of obtaining a sum of 10 or more. So a sum of 10 or more would be 6 plus 4. Make that a little bit. 6 plus 4. I have to look back at it. Okay, 10 or more. I forgot that quick. 6 plus 4, 6 plus 5, 6 plus 6. All are sums of 10 or more. 4 plus 6. Let's see if there's any more. I believe that is it. So 1, 2, 3, 4, 5, 6. Would be 6 out of total outcomes of 36. So that would simplify to 1/6. Okay, for this next question, it is asking you to determine if it is classical, empirical, or subjective probability. So it's very important to understand these definitions. So if you look under D, you'll see that in classical probability, the number of ways the event occurs and the total number of outcomes are known. This is when you think of probability, you probably think of classical, and then empirical is I like to say you're doing an experiment, because it starts with the E, just like empirical. And when you do an experiment, you're observing your data from the experiment. And then subjective, it's very subjective if you don't have maybe the data, but you're basing it on your experience and your personal opinion. And that's going to change from one person to the next. So subjective means it's very subjective, just like the definition of the word. So with this one, be careful. Some of these can be tricky. Beauty contest, that one's pretty easy. That's very subjective, and who you may think is beautiful or should have won may be different from another person. Okay, for B, the probability that no students will be absent from the next statistics class. This is empirical. You're going to have to observe this and collect the data from it. You can actually, how could you get the data? Well, the next day you could go in and count the number of students that are absent, or you can do an experiment today and observe how many are absent today, and use those results to do the probability for the next day. For C, the probability that the next card in the deck will be read. This is just classical probability. You have everything there. You know how many cards are in a deck, and you know how many are read. For D, the probability that the ticket will win the lottery. This is just classical probability. You can go ahead and determine the probability for that. Okay, for this question, it's just asking you basically to use the rule. I'm trying to move this over. To use the rule of probability. Remember, probability should add up to 100%. So we have 31% in creativity, 26% in keeping in touch, 20% in easier than texting. So how much would be left to be in the other category? So we already have 77%. So 100% minus 77 would leave 23%. Okay, for number 6, we're doing a survey of, and this looks like empirical probability because we are observing ourselves. So we're taking the information we have, and we're finding the probability of different scenarios. So if you look at A, it wants to know the probability that a randomly selected household has one cat. So let's go look. One cat. So the number of cats for one, there are 27 households. So we take what we observed in form of probability. 27 out of the total of 125. And I believe they want us to put this in decimal form, so you would just simplify that. 27 divided by, convert it, 27 divided by 125 would be 0.216. Okay. For the next one, it says the probability that a randomly selected family has more than one cat. So, greater than one cat. So that would be, you would add any row that has greater than one cat and the number of households. So 27 plus 12, which is 39, plus 4, plus 3. I believe that is 46. Out of 125, which is 0.368. The probability that a randomly selected family has cats. So this would be every row except the first one. So there's more than one way to do that. You could just take 125 and subtract out the 79 and see what's left for the other categories, or you could just add these 4 categories up. Either way, you're going to get 46 out of 125, which is 0.368. And I made a mistake, I see, on the last one, so let me fix that. Greater than one cat would just be the 12, 4, and the 3. So I apologize for that. So that would be 19 out of 125, which is 0.152. Okay, so I make mistakes. Y'all see it for yourself. And then we already answered D because we said it was empirical probability. Let's look at question 7. Here we're doing a total of 500 adults responded to a survey. What percentage of respondents chose other? Well, all you do is add up what you know, and we have 30 plus 17% plus 13 plus 12. So that would be 47, 60, 72%, and 100% minus 72% is 28%. For the next one, of the respondents, how many selected Part A? Well, 30% selected Part A, and we see that there are a total of 500 in this survey, adults. So you have to take 30% of 500. So 0.3 or 0.30 times 500, which is 150. For the next one, of the respondents who would select either Part C or Part D. So when it's or, we're going to add those two groups together, which is 25. And we're going to do 25% of 500. So 0.25 times 500 would be 125. And this is an example of empirical because we did a survey, we did an experiment, and we're observing our results. For question 8, let's go ahead and look at A. How many earned 100,000 or more? Well, we see there's a question mark there. Well, it has to add up to 28. So we would, if we added it up and subtracted, we would get 1 there. The probability of randomly selecting an executive who earned 100,000 or more. Well, 1 earned 100,000 or more. 1 out of 28. So 1 divided by 28 would be 0.036 if you rounded to 3 decimal places. For C, the probability of randomly selecting an executive who earned 60,000 or more. 60,000 or more would be 24 out of 28. So you would do 24 divided by 28 and get 0.857. I will continue this video in the next video.